So, Bismillah Rahman Rahim. So, let us start our module 1 for the design of the 10-story building. This is Engineer Finally, and I'm the course instructor for this design course using the ETABS and SAFE. In this module, we will be talking about the different structural systems, which consist of the bearing wall system, building frame system, moment resisting frame system, and bolt system. And then we will be talking about the types of the slab system, which is the beam slab system, which is commonly used. And then we have flat slab system, flat plate system, then joist systems, and the design codes. We will go through the design codes. So if you have any questions during the lecture, so you can note it down with your notebook, and you can ask the question at the end of the session, and you will have the 5 to 10 minutes for the question and answer sessions, right? So the first one is the bearing wall system. In this system, the loads are primarily resisted by the walls. You have commonly seen in the villages or in the town as well. And you can see on the uh, left hand corner we have the concrete brick masonry, which is the unconfined brick masonry, and on the right side you can see this is the brick. This is the concrete masonry, and this is the brick masonry, which is the unconfined. And on the at the top we have the confined brick masonry, where we have the confinement elements, which is the normally known as the confined columns. And then we have the tie beams, which connects all the confined elements. This is known as the confined brick masonry, or you can say the confined common word is the confined masonry, which can be concrete or the brick. Right, so brick masonry walls can be confined and unconfined. These two are the confined, which is the concrete unconfined masonry. This is the brick unconfined, and this is the brick confined masonry. And it resists all the seismic as well as the gravity loads. And as per the Building Code of Pakistan 2007, in table 15.13 in the structure system table, you can see that there is a structure, basic structure system. There is a column in which we have the first one is the bearing wall system, in which we have different type of the systems. For example, the light frame wall with the shear panels, it has its own R values. With the wood structure panels, this is the R values. This is the over strength factor for the amplification of the over strength factor, and this is the seismic zone heights for the zone 3 and 4. This is the height limit on the building. For example, if you are using, if I talk about the shear wall, the masonry, so for the masonry you have the R value of 4.5, omega is 2.8, and the building height limit is the 50 meter, and in feet you can say it is 160 feet for zone 3 and zone 4. You cannot build a structure having brick masonry to resist the seismic and the gravity loads, and it cannot be greater than 160 feet in height, right? So this is the masonry bearing wall system table for the Building Code of Pakistan. You can take the values as per your requirement. The next one is the building frame system. In this system, the loads are basically resisted by both the shear walls and the frame, which is consist of the beam and columns, and the lateral loads are resisted by the shear walls, and the gravity loads are resisted by the frame structure. And you can see that the walls are very large in the length, because it will resist all the gravity, all the seismic loads coming from the design earthquake. And the frame structure will consist of the walls, the columns and beams. It also can consist the slab column, which is the flat plate. It can also play a role to resist only gravity loads, and the shear walls will play to resist the lateral loads. So this is one of the frame system, and it also defined by the code, and it is the building frame system. It consists of the steel eccentrically based frames. It has own R values, omega values, and the building limits. And for the shear walls, if you are using shear walls of concrete, so you have to take the R value of 5.5, omega 2.8, and the building height is limited to 75 meters. So what does it mean if the R value is greater or less? Let me give you a small example in terms of the reinforcement. For example, if you are using a large value of R, it means you are telling the software that your structure is more tough. So it will give you less reinforcement because you will follow the special moment resting frame requirements as per the code, and it will give you less flexure reinforcement. But if you are using the R value smaller than 7, so you are telling the software that your system is very not that much stiffer as compared to R value is equal to 7. So the software will give you more flexure reinforcement because you will not follow the special requirements of that followed by the SMRF. Right. So this is a difference between the. Or we will talk about this in future lectures as well. The next one is the moment resisting frame system, and in this system, all the loads which are the gravity plus lateral loads are the resisted by the uh, frame structure, which consists of the beams and columns, right? So if you are giving the R value of 8 for the special moment resisting frame, and you are using giving different shear walls, so it will not change the type of the frame system because you have taken the R value is equal to 8. So let's go to the table defined by the Building Code of Pakistan, and this is the special moment resisting frame, which is known as the SMRF, and the for the steel it is 8.5, for the concrete it is also 8.5, and there is no limit on the height of the building in seismic zone 3 and 4 as well. But if you are using the IMRF, which is the intermediate moment frame, so the R value will be taken as 5.5, and if you are using the ordinary moment frame, which is the OMRF, so the value for the concrete is 3.5. So if you are using the R value is equal to 8.5, so the reinforcement will be less. Flexure reinforcement in the columns and the shear walls will be less. And if you are using the R value is equal to 3.5, the reinforcement in the column shear wall will be more because you will not follow the special requirements given by the code in your columns and slab, in your shear walls and in the beams as well. Right, so this is the major difference in the R values for the moment resting frame. I have included these topics just for the clarity of for the students. Otherwise, it won't have any connection with the design of the 10-story building. The next one is the dual system. In this system, the gravity loads plus the seismic loads has been resisted by the shear walls plus the frame, which consists of the beam and columns. Right. So the gravity loads plus at least 25% of the lateral loads are resisted by the frame, and the remaining 75% seismic loads are resisted by the shear walls. Shear walls will not contribute in the resistance of the gravity loads. Gravity loads, 100% gravity loads will be resisted by the frame, plus at least 25% seismic loads will be resisted by the frame, and the shear walls will only resist 75% of the seismic loads. And these are the examples for the dual system. It will consist of the heavy shear walls, and it will consist of the frame as well. So in this system, you cannot model or design your system in same model. So you have to develop or model two ETABS models for the this system. In one, we will design only frame for the only gravity loads, and the shear walls will only support the uh, seismic loads, but not will be in the gravity loads. The earthquake loads will not be applied on this model. The next model will consist of only the seismic forces, and the columns and beams will only contribute to complete the structure. So in this way, you can design your system, and this system is used for the stories greater than 50 stories. If your system is in the zone 2B, 3 or 4, you can follow this system. It is very it is not very economical system, but it is very good for the very highest building. For example, 100 stories or the 90 stories, 100 plus stories. You can also use the composite structures, but this system is also used in many of the countries. So this is the table explained by the Building Code of Pakistan, where you can use the different system. For example, if you are using shear walls with SMRF, so the R value is 8.5, and there is no building height limit. So that is why this system with the SMRF is used worldwide. If you are using IMRF, so there is a limit on the height of the building, so you cannot build a system or a building greater than 160 feet. Similarly, there is also no limit if you are using the steel system with SMRF, there is no limit on the height. The next one is the types of the slab system, and the first one is the beam slab system, which consists of the columns, beams, and slab. In this system, loads are transferred to the beam slab action to the columns, and it may be one-way or two-way beam slab system. And I would assume that you would know the what is one-way or two-way beam slab system. This is the left one. This is the one-way system, and this is the two-way system. If the if the ratio of the spans is greater than two, so it will be considered as a two-way slab. If it is less, sorry, if it will be considered as one way. If it is less, it will be considered as a two-way slab system. Right? For example, a panel of 20 by 5. So if you divide 20 by 5, it will give you a ratio of 5, which is greater than 2. So you will design that system as a one-way slab system. The next one is the flared slab system, which consists of the drop panels and column capitals to resist the shear forces. It does not have any beams. You can also use the beam, but only at the perimeter of the building. In this system, the loads are directly transferred to the columns, and the additional elements, which is known as the column capitals drop panels, are used in the column to resist the bungee demand coming from the superstructure. Right? So this is called as the drop panel. This is the column capital, and this one is the combination of both. It consists of the drop panel plus column capital. The next one is the flat plate system. In this system, the loads are direct transferred to the columns, and the additional elements, which is known as the integral beams, are used to resist the or shear studs to resist the punching demand coming from the superstructure. You can see it will consist of only columns, and then we have slab. You won't see any drop panels, column capitals, and the combination of the both. This is because of the limitation of the height. For example, if you are restricted to use clear height of 10 feet, and you have to model or construct a 16-story building, and then you have to use this system, because if you are using beam slab system or with drop panels, you cannot construct a system with a 16-story system, 16-story building with that system. So you have must go to the flat plate system. But this system, flat plate system and the flat slab system, they are not allowed by the code in the seismic zone 3 and seismic zone 4. The next one is the joist system. In this system, loads are transferred to the beams, slab action to the columns, and similarly, it can be one-way or two-way joist system. There are different terminologies used. The one-way joist system is also known as the rib system, and the two-way joist system is also known as the slab system. And you can see this is the example of the one-way slab system, which is known as the rib slab system, and the next one is the two-way joist system, which is known as the waffle slab system. In this system, you will have a very deep beam, and the thickness of the slab will be very small. For example, if the clear distance or the clear distance between the two consecutive beams is less than or equal to 36 inches, you must consider it or design it as a joist system. Maybe one-way joist or two-way joist system. Now we will go through these codes one by one. So let us start with the ACI 31814. You can use ACI 31819, you can use ACI 31808, you can use ACI 31814. There is no major changes in the strength reduction factors, or for example, the minimum criteria of the columns, beams, and slabs. You can use any edition of the ACI. So there are different chapters in this code. We will quickly go through these chapters. For example, the first chapter is the general. We will you will find out the purpose, general applicability, and the licensed profession. What will be he will be doing. So this consists of the general information of the design. This is the notation terminologies, and the fourth is the structure system requirements, which consist of the scope, material, design loads, and structure analysis, strength and stability. All of these requirements in the chapter number 4. The chapter number 5 consists of the loads, but it will not give you the values of the loads, that how much is the live load, how much is the dead load. It will refer you to the ACI ASCE 716, that you must go to this code and you find out the how much load you should apply on your structure. Chapter number 6 is very important, which is the structural analysis, and you can check the modeling assumptions, what should be considered in the during the modeling, what is first order analysis, elastic second order analysis, and all of these you can study. Chapter number 7 about the one-way slab. Chapter number 8 is about the two-way slab. We will be using this chapter very often, because we will be designing our slabs and foundation as a two-way slab. The next one is the beams. We will be using this chapter as well. It consists of the different sections: scope, general, design limits, and required strengths, and the reinforcement limits. What are the maximum and minimum ratios for the reinforcement of the beams, and then reinforcement detail. And this is the chapter number 10 about the columns. We will be talking about the different requirements of the columns, what are the design limits, what are the reinforcement limits. You can go through this chapter by yourself. The next one is about the chapter 11 about the walls. So let us go through the chapter number 9. You can study different chapters as well. It consists, for example, chapter number 18 is the earthquake resistance structures. We will also talk about this chapter, and we will be following this chapter as well, because it consists of the intermediate moment frames. What is it? It will explain ordinary, special moment frames, special structure walls. Actually, there is a difference between the special structure walls and the ordinary walls. And what are the foundation limitations, how we will design the foundation. It consists of all the information in this chapter number 18. We will be discussing and using this code time to time. So let us go to the chapter number 10. Which is about the columns, and you can study about what is the scope. This chapter shall apply to design the non-pre-stress, pre-stress, and composite columns, including reinforced concrete pedestals. So you can use this chapter for all of these. If you are designing a non-pre-stress column, which is the RCC, we are using, for example, the casting is done after the placement of the reinforcement, and then pre-stress, which is the post-tensioning and pre-tensioning as well. And then we have the composite columns. You can also design composite column using this chapter number 10. And if I go through the minimum criteria, for example, these are the different requirements for the minimum shear reinforcement in the columns that you must provide if you have less reinforcement in your uh, finite element model. So there is a section in which they have given the minimum reinforcement ratio. I have included in our lectures, but I wanted to go through this quickly. You can see that for the composite. For the non-pre-stress columns and for the pre-stress columns with average P area, which is the effective area for the stresses, area of longitudinal reinforcement should be at least 1% of the gross area, but shall not be greater than 8%. It means for the ordinary columns, the reinforcement limitation is from the 1% to 8%. Right, so we will be go through these code time to time, and I have included many sections in our lectures from this code. The next one is the ASCE 716. You can use ASCE 722, you can use ASCE 710. All of these will have the same values, but a little different values. The contents includes the general information about the code, combination of the loads, and the live load, flood loads, tsunami loads. And this chapter is also interesting. You can study it out. The seismic design requirement for the building structure. This is chapter number 12. So we will be interested in the chapter number 4, which is about the live loads. We will go through the chapter number 4. That's we told यही करना ज़ान सा लगे. So this is the chapter number 4, live loads, and there is a table that the minimum uniform distributed live loads. For example, for the apartments, you have to see the residential. For the access floors, for the office use, you must use the live load of 50 psf, and if it is a computer lab, then you have to apply 100 psf live load on your structure, right? So the first unit is the, for example, this is 50. So 50 is in unit of psf. You can see this is psf, and in the brackets it is kilonewton per square meter. So if you are using the units in psf, so you will take 50, and if you are using kilonewton per square meter, you will take 2.4 kilonewton per square meter. Just for the, this is the residential. For the residential, you have to take the, for example, 1 and 2 family dwellings, or the, for example, normally you will take the all other areas includes for your normal use of the floors except stairs. You have to take live load of 40 psf. For the corridor serving the public rooms, you have to take the live load of 100 psf. It is for the hotels and for the gymnasium and all the public places. For the hospitals, you have to use the 100 psf live load. For the roof, you have to use the 20 psf load for the ordinary flat, curve, or pitch roofs. So we will be using this code as well. The next one is the UBC 97 and the Building Code of Pakistan 2007 based on the UBC 97. If you are using this code or Building Code of Pakistan, both are the same code. So in this there is a volume 2, which is the structural engineering design provisions, and you can check it out the different sections. For example, in chapter number 16, structural design requirements, you can check the dead loads, live loads, no loads, and they have given the values taken from the UBC 97 and ASCE 716. So you can go through this chapter, this code as well, and you have questions. So you can text me or you can email me, right? The next is the building code of Pakistan, and we'll go through this as well. This is the building code of Pakistan, Seismic Provision 2007. So there are different chapters. In the first one is the scope, objectives, and the general principles. The next one is the seismic hazard, which consists of seismic zones and seismic mapping and the modeling of the ground motion. Site consideration consists of the different potential of the fault ruptures and the sensitivity phase, all of these. The chapter number 4 is about the soils and foundations, that the foundation consideration in the seismic zone, what will be the foundation consideration in the seismic zone, soil capacities, and the foundation soil interface. The chapter number 5 is very important. This is the structural design requirements. The general design requirement in the division 1, and the division 2 consists of the snow loads, and division 3 consists of the wind loads, and division 4 consists of the earthquake design. So in the first division, you will see the different loads, which is the snow loads, wind loads, earthquake loads, and these are the general definitions of these loads. The next one is the detail of the snow loads, that how do you take the snow loads, what will be the different parameters, and what will be the load combinations. The next one is the wind loads, and it is explained different methods as well. Method 1 is normal force method, projected area method, and what will be the factors for the open frame structures, and different parameters will be discussed in this wind load chapter divisions. This is very important. We will be focusing on this division 4, which is the earthquake design, and it explains the different standards and notation used in this code. What is the purpose? What is the minimum seismic design, seismic and wind design, and the occupancy categories and the height limits, which I have explained earlier. And there is also story drift limitations, what is drift, what is overturning, what is horizontal and torsion moments. You can study it out with yourself. So this is the static force procedure, equivalent static force procedure. We will be following this procedure. You can study it out as well. And these are the different dynamic procedures explained, the lateral forcing elements, and all of the non-building structures also explained in this chapter. Right? So let us go to this chapter. We can see this is a notation. It is explained the different notations used in this chapter, right? And then we have the general definitions of the different. For example, what is base shear? Base shear is actually the total design lateral force or shear at the base of the structure, which will be applied during the design earthquake, right? So you can check it out, the different definitions, right? What is dual system and all of these. What is moments, what is P delta effect. I will explain at the end of this course. It's not included in this course. This is actually a second order nonlinear analysis for the building to be considered during the design earthquake. There are different equations to be used. This is the static force procedure. We will be using this force, and there are different formulas given by the code, which is to calculate the base shear. And there is a limitation on the base shear, that this is the maximum limit, and this is the general formula. There is also the lower limit as well, that the base shear should not be less than this way, right? So there's also different methods to calculate the time period of the building. Method A, and there is also approximate method for the calculation of the time period, right? So this was the overview. I have gone through very quickly on the course, because we'll be using these codes time to time, and we will explain different factors and formulas in our lectures. So these are the differences. This was the end of the module 1.